Hi everyone, I am Ranjita. Today we are going to discuss about the digital signal processing. The subject code is BEC 402. In this, we are going to discuss about the analyze the Fourier transform and its application in signal processing. Firstly, the introduction to the Fourier transform. What is meant by this Fourier transform? The Fourier transform is a mathematical technique used to analyze the frequency components of a signal. It transforms a time domain signal into a frequency domain representation. This transformation is a crucial for understanding the behavior and characteristics of a signal in the various application. Here we can see the why and how does it works. The f of w is equal to the integration of the minus infinity to a plus infinity f of t into e power j omega t into delta t. The Fourier transform changes from time domain to the frequency domain and back again. Next, the mathematical definition. The Fourier transform of a continuous time signal is given by the integral. The formula express the signal has a sum of sinusoids with a varying frequency, amplitudes, and phases. The inverse Fourier transform allows us to recover the original time domain signal from its frequency domain representation. The properties of Fourier transform. The Fourier transform has a several important properties and including the linearity, time and time shifting and the frequency shifting. The properties allow for easier manipulation and analysis of a signals in the frequency domain. Understanding these properties is essential for applying the Fourier transform effectively in a signal processing. Here we can see the operation, that is linearity. The time function is a of f1 of t plus b of f2 of t. Then this is for a time function. Next we are going for a Fourier transform. We will get a is equal to capital F1 of w plus b into a f2 of w. Then time shifting f of t minus t naught. In the Fourier transform, it will be a f of w into e power minus j w into t naught. The discrete Fourier transform or DFT. The discrete Fourier transform is a sampled variation of free, the Fourier transform used for a discrete signal. It is defined as the x of k is equal to a sum of n is equal to 0 power of the n minus 1 into x of n and e power minus j 2 pi n kn for n samples. The DFT is particularly used in a digital signal processing where the signals are represented in a discrete time. The fast Fourier transform. The fast Fourier transform is an efficient algorithm to compute the DFT. It reduces the complexity from making a real-time signal processing feasible. The FFT is widely used in various applications such as the audio signal processing, image analysis, and the communications. The applications in the Arduino processing. The Fourier transform is extensively used in Arduino signal processing to analyze the sound waves. It helps in tasks such as noise reduction, equalization, and the audio comparison. By transferring the audio signals into the frequency domain, the engineers can manipulate a specific frequency ranges for improved sound quality. The applications of the image processing. In image processing, the Fourier transform is used for image filtering and enhancement. It allows for the identification and manipulation of frequency competence in images and aiding in the tasks like edge detection and the blurring. The frequency domain representation make it easier to apply a certain filters that would be difficult in a spectral domain. The applications in the communication, the Fourier transform play a critical role in a modern communication system that includes the modulation and demodulation. It helps in analyzing the bandwidth and signal processing and ensuring the efficient transformation and receptions of data. The techniques like orthogonal frequency division, multiplying, rely and heavily on the principles of the Fourier transform. The challenges and limitation, the discrete, the decept, its wide application. The Fourier transform has a limitation such as a poor time resolution for our non stationary signals. The trade-off between the time and the frequency resolution can lead to challenge in accurately and analyzing rapidly changing signal. The alternative methods such as the short time Fourier transform and the valid transforms have been developed to address these issues. The further trends in Fourier transform applications, the advance in computational power and algorithm will continue to enhance the capabilities of Fourier transform in a signal processing. The machine learning and artificial intelligence techniques are being integrated with a Fourier analysis for a smarter signal interruption. The future research may focus on a real-time application and the development of a new algorithm for better performance in the complex signal environment. Thank you, everyone.